All right, so yesterday we started on section 8, which is about climate change and global warming. We talked about what we defined climate, and remember, climate is the weather conditions that prevail in a certain area over a long period of time. We talked about how the Earth's climate has natural fluctuations that occur, but these natural fluctuations, the fluctuations that we're seeing now are no longer natural. Remember, the temperatures are rising faster than normal on Earth, and that is due largely to human actions. So remember, we talked about the greenhouse effect. We talked about the natural greenhouse effect. Remember, we have our atmosphere, and we have this greenhouse gas kind of blanket that naturally occurs. And when the radiation from the sun comes through that blanket, and then it reflects off of Earth. And remember that some of it is kind of trapped by that greenhouse blanket, but a lot of the heat escapes back into space. But because of human actions, we now have this human enhanced greenhouse effect, where that greenhouse blanket is a lot thicker. So the sun is still coming in as normal, and the heat is being re-radiated, but less heat is escaping into space, and more heat is being re-emitted and kept in our atmosphere, and that is causing the Earth to heat up. We talked about why it's bad if the Earth heats up. We talked about hotter average temperatures leading to more severe weather. We have drought, heavier rainfalls, and more frequent storms. We talked about the ice caps melting and how that can be bad for cities that are at sea level or lower. And then we talked about air pollution and mass extinction yesterday. Remember, I said that there are 3 big contributors to global warming that we're going to talk about. Yesterday we talked about general pollution and waste, and then there's energy sources, specifically fossil fuels and our use of non-renewable energy. And then we have animal agriculture, which we will get into next week. Remember that the first one we talked about was general pollution and waste. We said this is from vehicles, from production in factories, and from the use of non-reusable or non-biodegradable materials. Okay, today we're going to talk about energy sources. So, non-renewable energy sources. We need to talk about what exactly that means. So, if something is non-renewable, that means that the supply is limited, meaning that there's a limit on how much is available. And the reason that we say that it's limited, that for example, these non-renewable resources that we're going to talk about, why they're limited, is because technically, yes, if we use all of these resources like fossil fuels, which we're going to talk about here in a second, if we use all of them, technically they will regenerate, but it takes millions and millions and millions of years for fossil fuels to form. So we don't really have that much time. We aren't going to see them. We don't consider that renewable. For example, a renewable resource would be something like wind, for example. This is something that can be used over and over and over again, and it doesn't run out because it's naturally replaced. So wind or sunlight, for example. These are all examples of renewable things, right? If I use a bunch of sunlight to power my home, I'm not going to use up all the sunlight, right? So as opposed to using gasoline, fossil fuels, there's a limited amount of that. The sunlight that we receive from the sun is not, technically it's limited, but not in our lifetime, not in many, 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 many lifetimes. So a non-renewable resource is something that is limited and doesn't replenish itself quickly, we can say. So the main non-renewable resources are these things called fossil fuels, which you read about in the chapter. So fossil fuels, they are a natural fuel like coal and gas, and they're formed from, formed from the geological formed in geological past from the remains, meaning the dead bodies, basically, of living organisms. All right. So how does this happen? We're going to look at how some fossil fuels are formed. So millions and millions of years ago, the Earth had a very swampy environment, like here in this picture, okay? Some places, it was ocean, it was swamp. So we had a very swampy environment. We'll just say it's a very swampy environment. And there were huge plants, lots of plants. And there were volcanoes, lots of volcanoes, okay? So we have these plants, and they get in this swamp, and they get covered by dirt. And this dirt comes from a volcano or from a landslide. Something came over and covered and killed all of these plants, right? So now we have the dead plants down here, and they're covered by dirt. All right? And then millions and millions and millions and millions of years later, we have water on top. All of these animals and things die, right? And they're adding to this dirt, dead plant mixture. And then millions and millions and millions more years go by, and we have rocks and dirt all on top of this stuff called coal. So what happens is these dead plants, it's not just plants, it's also animals, any living organism, they get compressed. So that means squeezed together really tight by all of this pressure of the dirt and the ocean and all of this stuff pushing down on them. So when that happens, it compresses it so much that it turns into something called coal. And a similar thing happens down here with oil and gas. So it's exactly the same kind of idea. We have all of these organisms falling to the bottom when they die, right? And they get covered with sand and silt and dirt and water and over millions and millions and millions of years. And those plant remains and animal remains get pushed down, 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 closer to the center of the earth. And eventually that pressure, and over lots of time and with heat from the center of the earth, pushing them closer to the core of the earth, then we get oil and gas. We get oil and gas, and we get coal. So, how are these formed? That's the way they're formed through these pictures I just explained. The main thing you need to understand is that it takes lots of time. It takes a lot of pressure, right, from all that dirt and the water pushing down on the remains, and it takes heat. So with time, pressure, and heat, we're going to say lots of time. It's not just like 5 years. It's millions and millions of years. Time, pressure, and heat leads to the formation of fossil fuels. All right? So you're going to need to be able to understand that and be able to explain how fossil fuels are formed the way that I just did. Oops. Okay. So we have 3 main types of fossil fuels. And they are petroleum first. And petroleum is also called crude oil. Crude oil, aka crude oil. And crude oil is used for gas in cars and other combustion engines. I'm going to say used in cars and other combustion engines. It's used to make plastics. Different types of plastics. And other synthetic materials. It's not just plastic, but it's also used in heating and electric systems. And then we have natural gas, so that's petroleum, that's our first type. Then we have natural gas. Natural gas are things like, let's give some examples. Methane, you've probably heard of methane, or ethane. These types of gases are used for heat and lights, and they're also used to make plastics. Plastics also. All right. Okay, and finally our third type of fossil fuel is coal. And coal is used for electricity. It's used and steel. We'll say steel, the metal mixture steel production. And it can be turned into liquid fuel, but these are the more common reasons that it's used. When it's burned, when coal is burned, which is how we extract the energy from it. When coal is burned, it produces the greatest amount of greenhouse gases of all the fossil fuels. It produces the greatest amount of greenhouse gases what did I say? Of all the fossil fuels. Of all fossil fuels. All right. So these three types of fossil fuels, they're all used. They all have potential energy. They all have chemical potential energy stored within them. When they are burned, that chemical energy can be turned into radiant energy. Remember, that means light energy. Thermal energy, which is heat. It can be turned into mechanical energy, which is the energy of motion, right? So we have all of this chemical potential energy stored in our fossil fuels, and it gets converted into some usable form of energy by humans, right? So I said it can be turned into radiant, electrical, mechanical, remember mechanical means kinetic and potential energy, the combination of those two. So we have lots of different uses for fossil fuels, okay? All right, so what do fossil fuels have to do with the environment? Why are we talking about them when we're talking about global warming? So burning fossil fuels, which I just told you is how we get the energy out of the fossil fuels, how we convert it to some usable form of energy by humans. When we burn them, this produces what's called a combustion reaction. A combustion reaction. And this is a type of chemical reaction that, I'm going to say a type of chemical reaction. And a chemical reaction is something that it's a reaction involving molecules, and those molecules get rearranged, and we basically are rearranging the molecules to create a new chemical. Okay, that's how you can think of it. So it's a type of chemical reaction that produces carbon dioxide. Lots of carbon dioxide. Remember, that would be abbreviated CO2. And remember that carbon dioxide, remember when we were talking about, where did I write that? Where are our here they are, our main greenhouse gases. Our main greenhouse gases are carbon dioxide, methane, nitrous oxide, and ozone, right? So if we're producing tons of carbon dioxide, we're adding carbon dioxide up into the greenhouse gas layer, right? We're increasing the greenhouse gas layer. All right, so some things that burn fossil fuels would be and release CO2 into the air. Anything with an engine. Not anything. Well, yes, anything with an engine. We're going to say engines. Engines. And I just totally spelled that wrong. Engines. Burn fossil fuels. Burn fossil fuels, aka release lots of carbon dioxide into the air. We also have industries, which have there we go. Industries that burn fossil fuels to make electricity for their buildings. Industries burn fossil fuels for electricity. Right? So these are the two big main contributors to where we're getting this fossil fuel or the carbon dioxide pollution. Engines and industries. Those two burning fossil fuels lead to a ton of carbon dioxide being released into the air. So one other reason that fossil fuels are bad, not great, bad for the environment is through the extraction process, how we get fossil fuels out from under all of that. Where is the picture? Here, how do we get down in here? So if we're here, how do we get down here to the coal, right? How do we get down? If a lot of these oil deposits, you probably know this, there's some, it's called offshore drilling happening even in Mauritania. I think it's still happening. They don't have very good luck, but there's some oil in little pockets out in the ocean around Mauritania. So there's a lot of the oil that is extracted it's in the ocean, right? It's at the bottom of the ocean floor. So we have these big, actually I'm going to show you a picture of that. Okay, so here we have what's called an oil rig. O-I-L-R-I-G, an oil rig. These are all oil rigs, and they're out in the ocean. You see there's many in this picture, and what they do, let's get this picture over here. They have these big long apparatuses that go down to the ocean floor. They drill into the ocean floor until they get to the oil, and then they suck that oil back up into the rig and into containers. Okay, so this is a common extraction process. I mean, this is the way that they extract oil from the earth. So what that can lead to is some really big problems for our environment, specifically for the ocean environment. So here's this picture again. This is a picture of an oil spill, right? So there can be problems with the extraction process that lead to big, huge pollution events. Specifically, you've probably heard of the BP oil spill, for example. That's the biggest example I can think of. But there have been tons of different oil spills. So the extraction process, we have many different types, but this would be, the one that I've explained is called drilling. But there's also something called fracking. And there's there's mining. So these are all ways that we extract fossil fuels. And they all come with environmental impact. All right? Okay. So that's a lot of dire, sad information. Humans suck. We just are using way too many fossil fuels. But the good news is that because of all of these problems that have occurred, and are occurring, and these consequences that we're seeing now, we have come up with lots of alternative energy sources. And these now are renewable energy sources rather than those non-renewable sources like we were just talking about. All fossil fuels, that I think I said that, but I want to make it very clear. All of these fossil fuels, they're non-renewable energy sources. So we're just using and using and using and using and using. They're not going to replenish for a very, 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 very long time. And they're also really, really bad for the environment because of the amount of carbon dioxide that they're releasing into the air. These renewable energy sources are much more environmentally friendly, and they are renewable, meaning we're not going to use all of them to the point where there are none left. And then we're like, oh no, what are we going to do now? So I'm going to introduce these, and then we're going to stop, and I'm going to give you time to answer the questions. And I want you to read the section on nuclear energy before and the other renewable energy sources before I lecture over this. But I'm going to give you a brief introduction, and it's really important that you really, really, really spend your time reading this next section and listening to what I'm saying about these alternative energy sources, because you're going to do a project on this. So it's very important that you're paying attention and taking real good notes, all right? So we have, how many? I think I have 4 different energy or alternative energy sources that we're going to talk about. So the first one is nuclear energy. And there's some debate about whether or not this is technically renewable or non-renewable, but I'm going to call it renewable. For the sake of this class, we're considering it renewable. And this is where we have nuclear energy and energy, and we convert that to electrical energy. We have solar energy. This is energy from the sun. And this is radiant and or thermal energy. And that is converted to electrical. Next, we have electricity. And this is where we harness the energy from the motion of water. We're going to say hydroelectricity, and we're going to put wind power. We're going to combine these two. So it's where we harness the electricity or the energy of motion associated with moving water or moving wind, air particles, and we convert that into electricity. So this is kinetic energy, KE, abbreviated, remember that. Kinetic energy converted to electrical energy. And we're going to, like I said, we're going to talk way more about all of these, but I'm just giving you a brief overview of what to expect here. And then we have what's called geothermal energy. Geothermal energy is the energy that's harnessed from the internal heat of the earth. And we're going to talk about the process of how that's done later. So here we have 3 steps. We have thermal energy, which I just said is harnessed from the earth, the internal heat of the earth. Thermal is converted to kinetic, and then it's converted to electrical. And I will explain electrical, how all of that occurs when we get there. Okay, so all of these renewable energy sources, they have positive aspects and they also have negative aspects, and we're going to talk about all of them. But in general, these 4 types of renewable energy, these are less less harmful in general to the environment than the use of fossil fuels. So we're going to talk about those starting on Monday. Okay, so for the rest of the day, the rest of the time today, you're going to work on the section 8, part 2 questions. Those will be due Monday. And also due Monday, you will read and take notes on chapter 8.2, section 2 of chapter 8. All right, and those are going to be due on Monday as well. Okay, if any of you have any questions, none of you have said really anything to me on Google Classroom, so I assume everything's going well. If you have any questions, please let me know on Google Classroom. Remember that your quiz is next Friday, that you can go and watch the review video that is posted on Wednesday's lecture. Go watch the review video for Chapter 7 this weekend if you're studying. And again, let me know if you have any questions. Have a good weekend. Bye.